we will begin. So, uh, there are people who message me asking for help to catch up. Okay, unfortunately, they're not here. So, yeah, I would have offered to do it today. So, we will just push through, and then if they come in after this, then I'll see them during their labs. Okay. But if you didn't email me and you need help to catch up, to understand things, resolve some of your errors, stay behind, right? Stay behind. We will just have a few teach ones preparation. So there's three: Joshua, Ria, and Leia. Are they here? Leia's here. Ria's here. So Joshua's not here. Again, if you don't do your teach ones, I will ask you to present your final project. Okay? So that will replace your teach one. um, so those who missed their teach ones, you can still catch up, but you have to present your final project. And that means you have to have everything working because you cannot present your project if everything's not working. Okay, so this time we go back to the code. Last time we went back and to all of us, but just recreating the data set. We did a few codes, but this time we will go hardcore again. We wanted to really finish putting in the data sets, and most of it will be repetitive. So it will be long. The session will be long, but again, most of it are repetitive codes, and it will depend on the teach ones next week. If how we divide the teach ones. Okay, but if so, last week again, you're able to use our mapping file. I don't know if you've had your introduction to health informatics, but what we created actually was a data dictionary. Okay, some sort of a data dictionary, how to map what we need with what the data has, and how to understand what the data has is a data dictionary. So it's some sort of a data dictionary. So we use that in order for us to create the concept sets, the data sets, explore our concept sets to create the appropriate data sets, and then created the codes to update demographic data to match the requirements of the AI. Okay. Today, we will continue with updating the data. Actually, we'll finish updating the data today. There will be this will be like a big chunk of code. Again, you will see that it's repetitive. So if you know how we do things now, you have to really look into repeatable processes, right? Think about repeatable processes, put that into code, right? Design your codes or analysis frameworks into how can you do this repeatedly, and how can you design your analysis into something that can be adapted into different sets of codes, right? So what we did was, even with just my reference code, we can apply it with some minor tweaks to other antidepressants, right? So each of us are now processing different antidepressants, but we are actually using the same base codes, right? Same base design, and it's still working. Okay, so again, and then we will break into lab sessions. So this week is quite unique because our teach one, which was really made great by Amy. So thank you, Amy. She's not here yet, but she did a good teach one. But her teach one is only about creating of the data sets, the concept sets, and the data sets. We missed last week. We did not have Macy. She had something. Sorry, Lamis. She had something happen, and she will present her final project instead. So I hope that everything's fine now, Lamis. So what I did was I sent you the code in lieu of teach one. So where do you find the code? So you go to your Blackboard, okay, and then go to course content. And here is the source code for week 11, updating of the data set, okay. And then you can just um, download that and apply that. Um, okay, so yeah, so that along with Amy's teach one will be able to get you to finish this week's assignment. So I haven't created the submission link. I'll create it after the session. But this assignment will just be import your codes and use your mapping file. Um, and in terms of the mapping file, starting um, this week's assignment, you have created your own mapping file already. You submitted that hopefully last night. If you submit it late, I will not give you a full grade because starting now, I have made available the reference mapping file. Okay, so here we will use this for our mapping files. So we just click that. It will get you to the reference mapping file that we will use, and then just download it. Okay, so we will use that reference mapping file. It's also available in Blackboard in the course content section. Okay, but I guess yeah, it's not needed. I saw your work. Yeah, most of you did it right. But again, for uniformity, as I've told you, make sure that you create things that are repeatable and are easily understood and can be applied um, in different things. Okay, if you do that, I think in your career, and they will love you because you can clone yourself essentially doing that, right? You can, like, for example, that can teach 13 other people to do what he does, right? In the same quality. Okay, and then we rate Anne's teach one, and Amy's teach one. Yeah, good to know, Lamis. Yeah, yeah. Okay, so and then we prepare the teach ones for the next class. So this is where it becomes different. Okay, yeah. So let's talk about that. Let me say. Okay. All right. So this week is different because we have three teach ones. There will be Joshua, Ria, and Leia. So I will need you after this class. If you are not available, then you will present your final project. Okay. I already have like three people who will do so. I think Olufemi drop ish, right? And then I would also need people if they're available. Kwanda, Shakwanda, Macy, and Lamis, if you're already available, stay back as well. We need to start preparing you for your presentation, okay? Because I want you to succeed, okay? And you will need coaching for the method section to be able to really create the right content for your presentation. Okay, and then next week we'll have again 4 teach ones. Oh yeah, Johnny, I met him during the hymn session this week. I highly advise you to go there. It's really good. For $5, you have great food, and you will meet great people who can probably help you in your career as well. Yeah, and they have good speakers if um, you can attend, right? They Okay. So I will need Joshua, Ria, Leia, Shaquanda, Macy, and Lamis later. Okay, and anyone who wants like some coaching as well for the assignments, you can also stay behind and let's work it out. Okay. Um, okay. This is I'll bring it back here. So for today, we will do DXI and DXO. Okay. Remember, I am doing it for amitriptyline. For amitriptyline, only DXO has diagnoses, procedures, and measurements. Okay. For your own antidepressants, you might have DXI with diagnosis, procedures, or measurement. So you will just follow a similar approach with what I will do for DXO. Okay. Um, but again, what you will find out is I created like an sort of a repeatable process so that you will see that DXI, DXO, and PX will have very, very similar processes. Only the variable names, column names change. Okay. For RX, you will see that it's more complicated uh, than we expected. Okay. Again, Johnny and Ikra are pharmacists if they're here. It's not as simple as just like doxepan, right? It will also be doxepan 50 milligrams. There's a doxepan 100 milligrams. Um, but we are only interested in the doxepan active ingredient. So we will do a mapping file. So this is how I created my mapping file. If you remember, I gave you a mapping file for antidepressants. I also gave you primary technician, yeah. But still, like you see that there's coded differently, right, Ikra? Yeah. So I will show you later. It's really um, well, pharmacists are very detailed people. Very detailed people. We don't need that much detail when we inspected the AI, right? When we inspected AI, it doesn't need that much of a detail. It does not need the formulation, the dosage. It just needs the active ingredient, right? And interaction between two active ingredients, if possible, if there is, right? So remember, I created a grouping file for antidepressants where I group similar like doxepans, amitriptyline together. I manually created that using an approach that I will show you. So you will do that for your own medication data. I'm not able to because my approach is tailored to your own data. You have to do it yourself. I cannot like create cannot cannot create a master file because your data will be very, very different from my data. So, but the approach I will show you is again repeatable, okay, and easy to follow. Okay, we group the medications and then using that mapping file that we created, we will group medications together. And if there are interaction terms, meaning there are medications that says, for example, hydrocodone amicestofen or something. Uh, and then, so there's an interaction there. So if there needs to be, uh, if we need to form that interaction term, we will form that. Like, okay, we will do that. And finally, because we want to preserve this data set, we create a data checkpoint. Okay. Oh no, we're not gonna break out yet. So now let's go back to our all of us. So did you miss the screen? All right. So remember, I think it was Anne's teach one that we created a checkpoint, right? We created analysis df reduce as a checkpoint, right? So now what I do is just I don't have to run all of these, right? I just go here at the cell above importing of the libraries and reading the checkpoint. I go here. So it might be like for you, for me, it's a markdown cell. For you, it might be a cell. It might be a code cell. Okay. So I just go to cell and then run all below. Okay. So if I do that, okay, I don't have to again rerun all of my code from the top. Okay. That saves you a few minutes, right? Or hours if you're running the big disease data set, right? So I ran that. This is the data import from all of us that we created from Amy's teach one. Okay. So I will skip that. And then this is where we left off. Where Amy left off is where we renamed the data frames. So we have a birthday data frame, and then up to the medication data frame RxDF. Okay. And then the code that I will share with you includes these entire demographic data um, section, right? So, so this code, okay, is included in the code that I will share with you. All of them, okay, and yeah, okay, all of them, okay. So I will skip that. Okay. We will start with inpatient DXI data. So I will just make that neater. Okay, hold it. Okay, so we will start with processing inpatient diagnoses data. So so that I don't have to like scroll up every time, I just try to copy this as well. But again, if you have the code with you, you can just follow along with the teach ones later on. But I use that to guide me. Already done the birthday data frame last week. Okay, we will do DXI. For DXI, I only have conditions. Okay, so inpatient diagnosis data, and then maybe I'll add a markdown here just for um, condition data. Okay. So first I inspect, right? We wanted to like visually inspect our data sets. It's called exploratory data analysis. You will hear that a lot from industry speakers. If you is health and science careers week, just before this talk, I went into the data careers talk and then I learned a lot. And then you hear that a lot, exploratory data analysis. I think one of the speakers, Gabrielle, talked about that. So you will do that a lot because it's not just code that can inspect data. Our eyes are very good data analysts. Okay, see, okay, so here we see that okay, I did info just to see how many entries do I have in the conditions. There's 23,000 conditions for this entry, and then and I'm really interested in source concept code. That's the ICD-9 code, ICD-9 code, right? And there's no missing values. They're the same, right? And then I want to make sure that I have enough enough resources. It's less than a megabyte, so yeah, I'm good. I can process this even if my computer right now is very small, 8 CPUs, 30 gigs of RAM. Not the smallest, but smaller compared to what I used to use our previous assignments. Okay. I'm also interested in only finding out inpatient values. Okay, so we know that this column, visit occurrence concept name, has values for whether it's an inpatient or an outpatient visit. So we want to retain only inpatient visits. So to do that, to visually inspect, I want to get all the unique values of visit occurrence concept name. So these are it, right? From these unique diagnoses, for these unique visit types, right? I selected again manually. Uh, you can like consult with your friends, but for me, I think for me that only these are inpatient. So emergency room inpatient visit, inpatient hospital, inpatient visit, and nursing facility. So these are the only types of inpatient visits. The others are non-inpatient visits. Okay, so what I'll do is filter I will filter the data frame and retain only rows um, with these values as visit occurrence code type. Okay, and now once I filter that value, I no longer need this column. It has served its purpose. And based on my succeeding plan for the design, I also don't need end date. Okay, because I will only use start date for my date comparison. So I retained only the columns that I need, the person ID, the start date, and the ICD-9 code. Okay, and look at the head. Yeah, it looks good. So now I will create a temporary analysis data frame. This temporary analysis data frame, I will use it to create the dummy variables. And then once the dummy variables are created and have the right dimensions, meaning I have aggregated it, removed duplicates, and everything, I have really finalized this dummy variable set, then I will left join it again or add that to our final analysis data frame. Okay, so I created a copy of the analysis data frame with the standard concept code and the condition start time uh, using left join on person ID. So here we have the temporary analysis data frame. Again, we will just use this to create the dummy variables. And we have condition start time and source concept code. Visually inspecting, right? Visually inspecting, oh, I see NaN. NaN is not a number. So usually it's missing value, right? So there's a lot of missing values, right, for source concept codes. So, and there's also a lot of vision values for the condition start time. Okay? And so what I did was I wanted to remove any row for diseases that happened after the antidepressant trial. Okay, similar to our previous disease processing. Okay, so I will compare condition start time with this earliest AD start. Okay, but in order to make sure that the comparison works, I make sure that they're the right data types. So for comparing dates, we need it in the date time data type. So I change it to date time, both of them. Then I only retain entries where the condition start time is either empty, meaning that's why is NA is null. Okay, NAT is not a time, so it's also a missing value or a null value. Or if this condition start time happened before the earliest AD start or the antidepressant trial. So if the disease happened before the trial, or if the disease does not exist. Okay, technically that's what I retain. And then I filled in missing values for the disease for source concept code, the ICD-9 source concept code as 0. Okay, so that means we will have like missing disease. That might matter in the future. Okay, and then I dropped unneeded columns. So what we found out is now that condition start time served its purpose, we don't need it anymore. So I dropped it. So we have this finalized data set where concept code, instead of having a lot of empty values, we have 0 for those empty values. And this guy was removed. Why? Because this disease started 2008, February 7, right? Yeah. Which is after 2007, right? After 2007. So it was removed. So yeah, our code worked. So next is I will create a DXI per trial. And the intention of this DXI per trial is just to create the dummy variables. Okay. So DXI per trial, I get the primary keys, which are person ID, AD grouping, antidepressant, and trial number, and then the ICD-9 code or the source concept code. Okay. So this is the table. And then we create the dummy variables. So remember from our code mapping, I'll show the reference code mapping, that if it's a DXI, our columns start with DXI underscore. Okay. So to do that, when we create a dummy variable, we create a dummy variable based on the ICD-9 code or source concept code. We put a prefix DXI. So we make sure that the prefix is DXI, so it starts with DXI underscore, and whatever is the content of source concept code. Okay. And then once we create those dummy variables, we add that back to the Cs per trial. We drop source concept code. We don't need that anymore. Okay. We created the dummy variables already. So now we have the dummy variables, DXI underscore, and then disease source disease 0, DXI underscore diagnosis 428.0, which matches really well with what I have because I only have one DXI 428.0. And the column name that I created, DXI underscore 428.0, matches very exactly with the data column that we have created in our mapping file. That means we have a chance to automate our calculations using this data set. Okay. Just again, inspected the data and aggregated. Okay. So I aggregated this DXI per trial based on the primary keys, which is person ID, AD grouping, and trial. And for these columns, DXI 0 and DXI 428.0, I just got the max, right? So if you had that disease, then you have it, right? If you don't have that disease, then you don't have it. And in any time within the trial, you had that disease, then we will tag you as someone who had it. Right? If you never had that disease within the trial, then that's the only time that it will be 0. So we will get the max. As long as you have a 1, it's a 1. Okay. And then once we have aggregated or grouped by in terms of SQL, you group by and you aggregate using max. Then we left join. Now we can left join disease per trial, the dummy variables that we have created, onto our analysis data frame, like our master analysis data frame. This is no longer the temporary copy. right? We left join based on the primary keys. Okay. And then we drop the unneeded column because based on our mapping file, you don't need dxi underscore 0, right? So I just drop that. And your code might not, your data set might not have dxi 0 as well. So there's also a way to remove that error. I will show you later when we process the medication. Okay. And now I get a list of all the newly created dxi underscore columns. So dxi columns are any columns that start with dxi, right? And if there are any missing values, I just fill it with 0, right? So if the person is missing a diagnosis for that particular diagnosis code, we assume that the person did not have that diagnosis. Okay, it's called data imputation. That assumption is because we are in a statistics is we are imputing using a central tendency or the mode, the most frequent value. We are putting in the most frequent value as an assumption for missing values. And the most frequent value is you don't have a disease, right? That's the most frequent value. So that's 0. 0 means I don't have that diagnosis or that disease. And when we inspect, then we already have our analysis data frame with an additional column, right? DXI 428 but 0, and it will be 0 if that disease diagnosis that did not exist for that trial, and it'd be 1 if it existed for that trial. Okay. And it's a small data set, 25 megabyte, 24 megabytes. So yeah, I can still use my own small server. But even though it's already 1,600 columns, okay, with 1,983 rows. Okay. So now we do the same for DXO. Okay, so we do the same for our outpatient diagnosis. So we go back to our mapping file, and then I go to DXO. Now for DXO, I do have V codes, right? I do have V codes. So I will have measurements as well as procedures, and not just our based conditions or diagnosis. Okay. So DXO for conditions will be really roughly the same than than will be the same as DXI conditions, but instead of DXI, we're using the DXO data. Okay, so we're using DXO condition data frame. Okay, inspected that, and this time, instead of filtering based on inpatient visit occurrence, we will filter on outpatient visit occurrence. So again, so this is where one of the factors where we will differ, because the unique visit occurrence that you might have in your data set will be different from any other person's data set. Okay, so it will be, these are all the unique occurrences of visits. Okay, so for me, when I inspected that, these are our outpatient visits, office visits, non-hospital institution visit, outpatient visit, emergency room visit, laboratory visit, telehealth, pharmacy, ambulatory, surgical, ambulatory rehab, observation room, ambulatory radiology, home visit, and outpatient hospital. And again, I filter the data frame to only those that fit an outpatient visit. And now that I have filtered my data, I only need these dates, these columns that for further analysis, person ID, start time, and ICD-9 code, the source concept code. Okay. So this is our final dx condition df. Again, similarly, I will create a temporary analysis data frame. As you see, there's no change in this code. Okay, temporary analysis data frame, and it will just have condition start time and source concept code at the end. So remember, we ended with this dxi column. Now we added these two columns. We again change the dates to dates because we want to process them. We will only retain rows where either the date is empty, or if the date happened before um, the antidepressant trial. Okay, similar to what we did for DXI. And we fill any missing values of source concept code but with 0. And we drop the columns that we don't no longer need, which is the start time. We will come up with this particular temporary analysis data frame. Now we will create DXO per trial instead of DXI per trial. Okay. Again, with the primary key and the ICD-9 code or source concept code. And then we will create DXO dummy variables using concept code. But this time, our prefix will not be DXI. If you go to our mapping file, our prefix for DXO is just DX. Okay, DX underscore. So we change our prefix to DX, create the dummy variables, drop the source concept code. We no longer need it, and we have this. We have all we have a data frame where all of the dummy variables are created for each diagnosis, for each outpatient diagnosis that they have for the trial. Okay. Again, we aggregate using maps. Um, group by the primary keys, which are person ID, AD grouping, and trial number. And we left join. After that, we left join our dummy variables to our main analysis data frame that we are processing, again, based on the primary codes, person ID, AD grouping, and trial number. We drop DAX0 because we don't need it. That's an unneeded column. Okay. And then listed down all the columns that starts with DX so that we can fill it with 0 if we have missing values. And we have this. We have the data frame for DXO conditions. Okay, still a small data set, but our columns increased to 1,632 columns. Now we process DXO procedures. Okay, when we inspect the data, the difference is instead of condition start time and condition end time, we only have procedure time. We still have this occurrence concept name and source concept code, right? So again, we inspect what are the unique values for visit occurrence concept name. And as you see, every time I run it for different data sets, it becomes different. Okay, so it's different this time. So I just choose which are outpatient, so non-hospital institution visit, office visit, home visit, outpatient visit, and emergency room visit. Okay, and filtered my data frame based on these values, and then retained only the columns that we need. And DXO procedure will just have person ID, procedure date time, and source concept code. Okay. I will then left join again to create a temporary analysis data frame, but this time again use the DXO procedure data frame as your file. Okay, so here we will have procedure time and source concept code added in to the temporary analysis data frame. So our old data frame ended with this column. We again, repeatable processes, right? Repeatable processes. we can now again change dates to dates and then retain only. But now instead of condition start time, we use procedure date time. Okay, you have to remember we use procedure date time here. Um, and then retain only those that either have missing value for procedure date time or those that happened before um, the procedure date time. Right? Happened before before the antidepressant trial. Sorry, the procedure date time happened before the antidepressant trial. And we fill any missing values with 0 for source concept code or the ICD-9 code. We drop the unneeded column. We don't need the date and time anymore. We create, again, DXO per trial. I didn't even bother to change the code here because it's still DXO. Okay, the prefix is still DX. Okay, and now you will get this uh, code, this table with these dummy variables. There's just like one variable that we are interested in, and it matches really, and then it matches exactly with our V code column name, right? DX underscore V72.31. Okay. Aggregate again, maximum, use the maximum. We aggregate uh, and then group by the primary keys. Group by the primary keys. And we left join to our analysis data frame. We drop dx underscore 0. Okay. And then we fill again any missing values for dx columns with 0. And we add another column to our data set. Now measurement, instead of condition start time or procedure date time, we have measurement date time. So that's the only change that you will do, aside from, of course, calling the DXO measurement data frame. Okay. So we check again for valid outpatients. For outpatient, we will choose outpatient header 1, and outpatient header 2. But this time, measurement type concept name is what we're interested in to find whether it's outpatient or inpatient. So I add measurement type concept name instead of visit occurrence, visit occurrence type concept name. It's measurement type concept name. So we have 2 outpatient concept names. We only retain those data that are for outpatients. And then we remove this column from our analysis. We only need person ID, measurement date time, and source concept code. Okay. Then we create our temporary analysis data frame again now using the measurement data frame. And our temporary analysis data frame will have our original data frame that ended here, plus the measurement date time and the source concept code. So now we change the dates to dates, date types, okay? The date types of dates to dates, and use measurement date time. And we only retain those measurements that do not have a start date or that have start dates that happened before the antidepressant trial. And we fill any missing values for the ICD-9 or source concept code with 0, and then drop any unneeded column. So the date time we no longer need it, so we drop it. And we have our data temporary analysis data frame, and the last column will be the source concept code. And we create a DXO per trial again with the primary keys and the source concept code, and we create the dummy variables. Again, prefix is DX, and we have this as a dummy variable. We are interested in V76.12. We aggregate using maximum, group by the primary keys. We left join now to our analysis data frame, drop dx0, okay, and then fill any missing values with 0, and we add that column in. Okay, so now we have 1,634 and columns, one more than we previously have. So we're done with diagnoses. Your diagnoses might have DXI procedure, DXI measurement. So just follow the same approach as DXO, but this time your algorithm will be for inpatient. So you will only select inpatient rows, and your prefix will be DXI instead of DX, and something like that. So just adjust the code so that it will fit DXI or DXO. Okay. All right. Now we have procedures. So we inspect procedures similarly, similar to our DX procedures, right? It has procedure date time. Okay. I accidentally downloaded standard concept code. I think we will just use source concept code, but they're the same anyway. But for you, I think if you follow Amy's Teach One, you will just download the standard concept code. So no worries on that. Okay. And now we will create a temporary analysis data frame. Okay. Because we retain only person ID, procedure date time, and source concept code. And then convert the dates to dates. And I use procedure date time for my dates column, and only retain rows where, again, procedure date time is either missing or happened before the antidepressant trial, and then fill any missing procedure codes. So these are CPT4 codes, not ICD-9. So any missing CPT code with 0, and drop the date time because we no longer need it. So we will end up with something like this. Now we will create PX procedure per trial using the primary keys and the CPT4 code for the procedure code, and then create our dummy variables. But this time our prefix will be PX. Okay, so if we go back to our mapping file, our column names are PX underscore the code. Okay, so our prefix will be PX. And now, and we will drop the source concept code because we no longer need it after doing the dummy variables, and we will have this table, which we will aggregate again based using maximum, group by our primary keys, and left join on our analysis data frame. Okay, drop px0, and then fill missing values of px. So px columns with 0. Okay, so I did that correctly in the code, not in the comments. And then you will have this, right? px columns added. And last but not the least, our medications. So this is a bit more, as I've told you, a bit more involved. Okay. So when we do our inspection, right, we downloaded a lot more stuff. And we downloaded a lot more stuff. And just one look at the RX data frame, there's already 600,000 entries. So we know that it's bigger than the others. The others are like only 3,000, 5,000 entries. This is 600,000 entries, 200 times more, right? Um, so we also look at how it looks like. So we called head, and we can see right here that acetaminophen, right? In our mapping, sorry, I'll just go back to our mapping, and we'll go to Rx, and then in our mapping, acetaminophen, we actually don't use it. But acetaminophen is just Rx code 161, right? But here, when we inspected that, it's not Rx code 161. It's Rx code 307668, right? And acetaminophen, but 325 milligram with oxycodone is different, right? 105, 04, 90, and so on. And that it will really vary. So what we will do is manually again create a grouping file, and I'll show you how I did it so that you can do it for your own antidepressants. This is a step that you will probably use in your other group dataset mapping as well. Okay, so I only selected for the mapping file. I'll only select the columns that I need, which is the standard concept code and the standard RX one, and the name. I want to like visually inspect or read that there's acetaminophen for this RX code. Okay, and then group them together using the mapping file. Okay, so use our original mapping file to create another mapping file that will help us group this data. Okay, so I will select all of these three columns. Okay, create a selected data frame. Drop any duplicates. I only need unique combinations of name, code, and vocabulary. Okay, and then write that to a file. So I write that to a file. I use the data folder that I created because this is data. It's not checkpoint. It's really like a data set. You can, if you just want a default folder, then do that. But again, I use the data folder. So once I ran that code, I will stop. I will not run this code. So we will run this code. It will create a data file. So you go to File, Open, go to your folder that you put in, and download that particular file. So this is selected RxDF. That's the file. I'll download that. I'll have to type affirm here. Click OK. And then save that where I want it to be saved. Okay. Once it's saved, we will use Microsoft Excel to open that file. Okay. To open that file, okay, and I will just expand these rows, this column widths, so that I can read. Okay. And then we will save as, so file, save as, selected RxDF underscore group, okay, and then put it in the directory that you wanted to save it on. So I will save it on my working directory for this colors. Okay, and then save it here. Okay, but I won't because I have that file. Okay, so once you have saved that as that, we will create a filter. We will create another column. I will just bring that new file in. I'll save. So this is the file. So we will create a new column called rx underscore code. Okay, so that's the new column. And then we will click on this sort and filter and create a filter. Okay. For this, I won't save this, but I will just delete everything. Okay, delete everything because this is the state of the file when you do it, right? Rx code will be the empty. You have created a filter, okay, and then you have to put in manually Rx code. So what we do is in our mapping file, here we filter to Rx, okay, and then look at what data we need to get. So here we need amitriptyline, okay. So I will just get amitriptyline. In the standard concept name column, click the filter button, and then in the search, click paste amitriptyline. Click OK. Okay. So the Rx code will be for this. These are all amitriptyline, right? Will be 704. Okay, so just copy this and paste that here. I paste it as a text. Okay. This is important. This filtering is important because if I didn't filter, right, it will seem overwhelming. Just my small amitriptyline data set has 820 different types of medications that should have been mapped to 15, right? 15 became 820. Okay, so that will be overwhelming if you don't have a process. So this process that I have created will help with that. Okay. Next is I'll go again to the next one, which is um, amlodipine bisalate. Okay, I just copy that, put this in. Okay, and then for amlodipine, it should be this code, right? Mhm. And then copy it in. Control C, Control V, okay, and do that, okay, for a lot of things. Now, there's a special scenario for some of you guys where you have interaction terms. Okay? So, for example, here, hydrocodone and acetaminophen. Okay, so for this one, select hydrocodone first, but whichever, right? But just to have um, and then tag it everything as with the RX number of hydrocodone. In mine, it is 5489. Okay, and then copy that up to the bottom. Okay, and then now select acetaminophen and then try to search that again. And you will find out something different. There are already um, medications with that interaction, acetaminophen and hydrocodone. It was not present when we were mapping. Okay, so for this time we remove the blanks. Okay, we retain them, And then these are interaction terms. So we put in 5489 underscore 161. Okay? Because these are interaction of two drugs. A drug with an interaction of two active ingredients. Okay. And then copy that to the end. And then remove the filters. Okay. And now, since this search term is still acetaminophen, right? This search, just to be sure, let's just put in acetaminophen again. Okay. This search term is still acetaminophen. Then filter those that are only acetaminophen. Okay, so only blanks. Okay, and then this one we tag with the acetaminophen Rx code, which is 161. So now you have drugs that are either just acetaminophen, just hydrocodone, or both hydrocodone and acetaminophen. There's a lot more acetaminophen. Okay. So computer is not working well. Okay, so if that's done, okay, if that's done, cancel. Again, you will just probably copy this to the entire stuff, right? You will save it if you're done with everything. So I will not save it because this is actually pre-filled. After you have completed it, which your file should be complete and looks something like this, right? So interaction terms, singular, individual, um, active ingredients. Okay. So now, when you have completed, we can go back to the code. So back in the code, again, back in your Jupyter notebook, you have to. This will not be here, so I will delete that to be safe. Okay. Now you will not be here. Then you will just upload, click OK here. Browse that file that you have just created, selected Rx under DF group, CSV, upload it. Now you can run the next code. When you run the next code, you will see your mapping file as a data frame. And then we just left join. So for all your Rx data frame. And then we don't need the name anymore, right? We don't need the ring anymore. So instead of dropping it, I just selected here the columns that I need, which is standard concept code, standard vocabulary, and Rx code. And then the keys for the join will be standard concept code and standard vocabulary. We do left join. And now we will have your Rx data frame with your Rx code that fits the mapping file. Because we have that, we no longer need this standard concept name, standard concept code, vocabulary. We don't even need the end time. So it should be, don't even need the end time, right? So we drop them. We drop unneeded columns. So we only have person ID, the start time of the drug, and the Rx code. And then we also, drop duplicates, okay? Because there might be drugs that have the same start time. So we just remove them and reduce our data set. And then now you can go back to that process that we have designed, where we create a temporary analysis data frame using our medications data. And then And then process dates, which we will use the drug exposure start time, and only get medications where the drug exposure start time is missing or the drug exposure happened before the antidepressant trial. And then any missing values for the RX code, we put 0 and drop the date column because we no longer need it. So now we have our temporary analysis data frame with the RX code here. We will use that RX code to form our RX per trial data frame, which is just the primary keys and the RX code, and create the dummy variables from this table. Prefix will be RX. So if you go to your mapping file, all of our data columns for your RX are started with RX underscore. Okay, and then we drop the RX code column, we no longer need it, and then you will have this dummy variables created. Again, we aggregate using max and group by the primary keys. We left join back to the analysis data frame. Left join back to the analysis data frame. And here is a code if you errored out use dropping the RX0 column, it might not exist. So if RX column is in the columns, right? If RX0 is in the columns, then drop the column. If it's not, then you don't need to drop it. Okay. And then get the list of RX columns and put the 0 for missing values. So we have our data set with all the medications. Okay, but that's not the end. Again, you have interaction terms. So you have drugs that are specifically that specifically have these two active ingredients together. So they're already interacting, right? So that formed our 5489 underscore 161 or whatever interaction drugs that you are using. But there might also be interactions between separate drugs that they are taking at the same time for the same trial. So if they are taking this is hydrocodone, or if they are taking acetaminophen by themselves, but together, they might also be interacting. So we have to create an interaction term. So the interaction term will only exist if all three columns exist. All the interaction term column and the individual term columns exist. And if they exist, what we will do is just make them as a float so that our processing later works, because what we will do is we will just multiply them. Okay, if this is 1, then it's okay. We found an interaction drug. It's the guy is taking an interaction drug. But if this is 0, right? If this is 0, then we will multiply 5489 by 161. Okay. If the row is 0, then we'll check if it's really 0. Because maybe there's an interaction between different drugs that they're taking that's equivalent to taking that particular drug. Okay, and then so this is the row 549161. Okay, so if there are interactions between this and 161, we will know. Let's see, 549161. So here 00101. So yeah, there's no interaction. Okay, and then do that for all of your interaction drugs. Okay, so this code is just for one interaction. You will just repeat this code for each of your interaction drugs. And because that took a lot of time, we don't want to do it again. We'll do a checkpoint. So we write this into a checkpoint file. But remember, we already created a checkpoint file for analysis DF reduced. So I just renamed it to analysis df reduced underscore pre-AI, before AI calculations, right? Before AI calculations. That's why it's pre-AI. And then we can read it again back in our analysis df reduced later on. And that's it. We're almost done. So our next steps will be just to predict outcomes, right? Using the mapping file and the data that we have, calculate prediction and evaluate those predictions. Know true positive, true negative, false positives, and false negatives, and calculate metrics. And then if this code is short, then we can calculate likelihood ratios. Okay. All right. So that was really long. Okay. But our assignment for today might be easy, so that, and it's a good thing, so that you can have more time to do this very long homework, very long task, right? So our assignment for today, once you got the data import as per Amy's teach one, then the code is available, and then you can just like download it, study it, copy paste it, edit it based on your coding like practices. Okay, so that you can like have probably more time to start this bit more lot more lines of code, but pretty repetitive, right? Pretty repeatable processes. Okay. Okay. Now that that's done, I'll stop recording. Pharmacy technicians. Okay, now because Amy's not here, I will still go around to groups. I will not have a teach one person to help me go around the groups, but we will now just use a breakout group. How many of us are here? 14, including me, so it's 13. So maybe 3 groups. So yeah, let's do one. Maybe 4 groups. Yeah, 4 groups. I'll do 4 groups. 1 group of 4, 3 groups of 3, and I'll see you in your groups. Yeah, see you there. Oh, sorry. Before I forget, we will end by, I shot 8:30. We will end by 9:10. Okay, 9:10. We will end by 9:10. We will return to the main room by 9:10. And I will need Joshua, Ria, and Leia to stay behind. And those that will also need like coaching, I think can stay behind as well. I think Macy emailed me. And then those that will want to present their final project instead of doing a teach one, like Macy and Lamise, also stay behind. And Shakwanda, if you're here, also stay behind. Yeah. Okay, see you.